Yes, good morning, metric students. Good morning, grade 12. Um, this is Nicholas, and I'm here to teach you electric circuits. So, this topic we have done it term 2, and term 3 is just the continuation of this topic. So, we'll try to go through the notes and do some questions regarding the question papers. So, yeah, make sure you listen, pay attention, and write something, take notes, and learn. You can never learn too much from anybody. Every day we live to learn. Every day it's a new day to learn something new. Okay. So I got this notes summarized here. Electric circuit. We'll start with the definition. Then, if the video becomes too long, then I will cut it, and then I will make another episode where I will be doing question papers regarding electric circuits. So let's start with Ohm's law. Electric circuits is all about Ohm's law. Let's start from Ohm's law. What is Ohm's law? Okay. As you can see, let me try to zoom this a little bit. As you can see, Ohm's law, for a conductor at a constant temperature, the current is directly proportional to the potential difference across its ends and inversely proportional to the resistance of the resistor. What does it mean? Like, for a conductor at a constant temperature, the temperature must be constant, right? And the current is directly proportional to the potential difference and inversely proportional to the resistance of the resistor. That is Ohm's law. Simple as that. Just keep your temperature constant. Then I equals to V over R. I directly proportional to V, meaning that when we increase current, voltage will increase, or potential difference. Some textbooks they call voltage potential difference. Some they call it potential difference. Some they call it voltage, which is measured in volts. So current is, when current increases, voltage increases, but current is inversely proportional to resistance, which means when current increases, resistance decreases. When resistance increases, current decreases, and temperature must be constant. So that is Ohm's law. You gotta know how to use the formula I equals to V over R. You'll see when we apply the formula doing previous question papers. And ohmic conductors are conductors that obey Ohm's law. There are non-ohmic conductors and ohmic conductors. Some conductors do not obey Ohm's law because uh, here examples are not included, but I would say a diode, it is a non-ohmic conduct. And then ohmic conductors can be copper, anything that can conduct what? Electricity. Right, right. Internal resistance. We got internal resistance and external resistance when you're using the EMF formula, which I'm going to show you later. Internal resistance, which you can see by the uh, IR with the small letter R, and then external resistance you see with the IR, which is the big capital letter R. External resistance is the big capital letter R. Internal resistance is the small letter R. Don't confuse the two. Internal resistance, the resistance within a battery that causes a drop in the potential difference of the battery when there is a current in the circuit. The resistance within a battery that causes a drop in the potential difference of the battery when there is a current in the circuit. So all these definitions, guys, please, you need to know them preparing for an exam. If you go to an exam without knowing all this definition, all you know is to use the formula at the back of the question paper, you are half prepared. You gotta be fully prepared. Okay, you gotta pass a metric. You gotta make sure you pass metric with quality results. EMF, they call it electromotive force. EMF. What is EMF? EMF is the maximum energy dissipated. Dissipated is when something is losing value, like dissipates. I think dissipates is when something depreciating, I guess. The maximum energy dissipated by a battery per unit charge passing through it. Or you can use two, there are two different definition. You can use this one: the potential difference across the ends of a battery when there is no current in the circuit. I think this one is simple, straightforward, but most textbooks they prefer this one definition for EMF. It says the maximum energy dissipated by a battery per unit charge passing through it. So it depends on the individual which one is easy for you to remember. Don't use CPF method. Just make sure you read this definition each and every day so that it will stay in your mind, if it wants to stay though. Let's go to equations and formula which we're gonna use to do calculations when it comes to electric circuits. Okay, because to be honest, to master physical science, I'll just give you this advice. Just know the definition and how to apply the formulas. That's it. When it comes to question papers, one, calculating the current, resistance and potential difference, we use Ohm's law. R equals to V over I, or V equals to IR when you cross multiply, or R equals to V over R, I equals to V over R. Like this formula, R equals to V over I, it applies in different scenarios. And then how to calculate resistance of series resistors. Series resistors, you can see that resistors are going in the same direction, straight line. So you're gonna say RS, resistors in series, equals to R1 plus R2 plus R3 plus R4 plus R infinity, depending on how many resistors are in the circuit. What I've noticed is that resistors in the circuit can be like there will never be more than 5 resistors in the circuit, I guess. Most of the question papers I've seen. So three, calculating the resistance of parallel resistor. Parallel and series circuits are not the same. So R parallel equals to 1 over R plus 1 over 2 plus 1 over 3. Sorry, man. 1 over R1 plus 1 over R2 plus 1 over R3 plus. This is the formula we're going to use to calculate resistors in parallel. Or when you only have, when there are two resistors in parallel, we use this formula. R parallel because equals to product of resistors divided by sum of resistors. Let's say R1 times R2 divided by R1 plus R2. Okay, we times at the top and divide and add at the bottom. We only use this formula when we got two resistors in parallel. If we got three resistors in parallel, we gotta go and use that formula. The first one, R parallel equals to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4 plus 1 over R5. Yeah. So for calculating internal and external potential difference, like I said, look, V internal, okay, voltage internal, we're talking about voltage inside the circuit, and V external, we're talking about voltage outside the circuit. So V internal equals to I times small letter r, because it's the internal resistance. V external equals to I times big capital letter R, because R, big capital letter R, is the external resistance. You need to make sure you remember this, because if you make mistakes, you will get everything wrong. Look, this thing inside this box, V internal being the potential difference lost in the battery due to the internal resistance R, and then V external being the potential difference only in the external circuit, but it's not the EMF. Okay, this is the difference. And then EMF is the sum or total of both the V external and the V internal. So E equals to V external plus V internal. This is the formula when you have to calculate the EMF of the circuit. And let's continue. So we're still on the formulas, right? Calculating the EMF of the battery. This is the formula you're gonna use to calculate EMF of the battery. EMF equals to current times, brackets, external resistance plus internal resistance, and then you're gonna have EMF equals to IR plus IR. IR difference is the big capital letter and small letter capital letter. That's it. And then EMF equals to voltage external plus voltage internal. Voltage external is IR. Is current multiplied by external resistance. Voltage internal is current multiplied by internal resistance. So, guys, to understand how to apply the formula fully, advice I could give you is to practice previous question papers. Don't just do two question papers and feel like you are ready. You gotta do more. The more the better, the more you understand the content. Calculating the power dissipated by the battery, we're going to use this formula. Power, electricity is very, very expensive. This formula, we're going to use it to calculate what? Power. Okay, look at this thing. P equals to W divided by change in time, or P equals to voltage times current. All these formulas are provided at the back of your question paper, but you need to know how to apply them in question paper in answering questions. Since V equals to I times R, P equals to I times R times I, then that's why we got I squared, because we said P equals to IR because of the voltage of external resistance, and then we got P equals to I2 times R. This is the formula you're going to use when calculating power when you are given the current and the resistor. And this is the formula you're going to use when calculating power when you are, or work when you are given work, or energy when you're given change in time. So you need to know how to apply these formulas. Since uh, since I equals to V over R according to Ohm's law, then you're going to replace that R by V over R. So it's go. I mean the I by V of R. Then you're gonna have P equals to V divided by R, and then P equals to V squared divided by R. So important to know. Sapt. What does sapt means? Series resistors are potential dividers. Wow, this is nice. The way they summarized it is nice. What does it mean? Series are potential dividers, which means that in series resistors, the potential difference splits, but the current remains constant. In series resistors, potential difference voltage splits, but the current remains consistent. Constant. Them not consistent. Constant. And then the paid it means parallel resistors are current dividers, which means that in parallel resistors the current splits but the potential remains constant. Guys, please make sure you remember this simple summary of electric circuit before we do question papers, because right now we gotta go and check out question papers and practice different questions and see if we are ready for the exam or test, upcoming test, when it comes to this topic, electric circuit. Know the definition, know how to apply the formula,